Hello everyone. And so Ian already mentioned this, but there are number of works in research trying to use plant models to provide data for machine learning. So this is an example from Calgary's group, where they model maize and canola for performing vision tasks based on the rendering of those plants. And so actually we already did things similar with Eleanor, who is a member of Sony CSL team as part of the roaming project, to do the segmentation for the scanner, the plant imager pipeline that you may have already seen the result of. So we were generating virtual plants and training image-based segmentation algorithm, and then based on the multiple segmented images, we can reconstruct the plant in 3D and give labels to each point, like which points are fruit, which points are leaves, which plants are stem, etc. And can we switch back to the main presentation, please? And so what we did, and we presented this in CVPA, a workshop for computer vision problems in plant phenotyping and agriculture, with Ian and Christophe team members, is to try to do the segmentation based on virtual plants, based on training on virtual plants, but directly with a point cloud. So can we switch to the next slide, please? And so for this, you need specific architecture. So like for vision, what people commonly use is convolutional neural networks. But for point clouds, it's complicated to think of a convolution operator. So you may think, let's take a grid, a 3D grid, voxel grid, and do 3D convolution on the grid. But to represent a plant in a 3D grid, you need a lot of voxels. And so to keep reasonable computational cost, you may reduce the voxel number, and it results in poor resolution point clouds. And so you have many techniques, and it's not really a solved problem, like what is the best representation for a point cloud to have it as input of neural networks. So as I said, there is voxel grid, there is image-based representation, like what we did with Eleanor and team, and there is also, you can represent your point cloud as a graph, and there are some architectures for graph, neural networks for graph. But one of the original techniques which was developed quite recently, like let's say 3 years ago, 4 years ago, is it's called PointNet. And so PointNet is a stack of multi-layer perceptron, and it's designed specifically for unordered set of points. And so PointNet++ is an evolution of PointNet which take hierarchical architecture to solve the problem. And you saw here some result of segmentation. So it can be used either for classification or segmentation, and it works quite well on segmentation. Can we switch to the next slide? And so to train PointNet++, we decided to use LPy, and the model provided by Christophe during the roaming project, and the sampler provided by Ian in the roaming project too. And actually the sampler, we found out, because I was kind of surprised, because you would have some sampler in PyMesh, for example, which use Poisson sampling, and it generates a point cloud from the OBJ file provided by LPy. And I was quite surprised that the result of the learning with the the sampler, like visually you can see the sampler from PyMesh is giving much less high quality, much less quality in terms of point cloud homogeneity and etc. But I was surprised how it affects the learning, the result of learning on Poisson sampled point cloud is much worse than using the method by IAM. So it seems important to sample in a wise manner your mesh. And so you see here the first figure, which is the LPI mesh. You see then on B the ground truth labeling using the method described by IAM. And you see the result of segmentation after training on 1,000 Arabidopsis plants. And so the question now is how it transfers on real plants. And so we tried this on D and E, and you see that it kind of works, but there are some problems at the tip. You see the main stem at the tip is not well segmented, and the leaves at the base, you see the leaves are not well segmented too. And so we think it's due to the model having flat leaves and quite straight stem. And so we saw this week, thanks to Christophe's training, how it can be solved by refining the model in LPI. And yes, just I want to mention, because Fabrice, just before, he told something which is resonating here, where he said we want to develop automatic method, but we still need to do a lot of manual measurements to check that the automatic method is working well. So it's a bit disappointing because you work a lot for automatic stuff, but you end up doing a lot of manual work. And here it's the same, because to check the quality of the segmentation here, you need to annotate manually the point cloud, which is very painful. Like already for images, it's a pain to draw the contours of each object, etc. But here, if you have to select manually the points which are part of the fruit, so it's very painful. But so you have to do it to check that your automatic method is working well. And but we do it with light heart because we hope it will be finished one day. We won't need to do it anymore. So as a conclusion, we trained on a virtual plant. When we tested on virtual plant, we got quite a good result, like a mean intersection over union greater than 0.8. As I said, it's sensitive to the sampling strategy of points on the mesh. And then we tested on real plants. We saw that the leaves because we tested fishbone Arabidopsis without leaves or with leaves, and we saw that the leaves make the segmentation difficult. And so now the next step is, thanks to the measurements of Fabrice, to try to make the model more realistic and see how we improve the learning. And I must also, so for segmentation, PointNet++ is great, but we are thinking of other tasks we could do with LPI. We could train maybe to predict the next point cloud. So you have development of your plant up to time t, and you want to predict what it will look like at time t+1. And so there are several architectures which could be used for that, and Mona is working with us on this problem. And for example, in NLP, people use in natural language processing, people use transformer architectures, which is based on attention mechanism. And transformers are currently invading all deep neural network domains. So you have transformers for vision and also for point clouds. So we are looking at how it could solve a problem for prediction. And in a way, if you can predict the next appearance of your point cloud, it's a way to model the growth of a plant with a neural network. So that's all I had to say.
Okay, thank you.